Hi everyone, welcome to AI Crack channel. This is Akash Gangar and today we'll be studying limits lecture 4 and we'll be talking about sandwich theorem, few examples of expansion series and the last set of indeterminate forms. Right. So let's begin a lecture with one example from previous lecture, that is of expansion series. So we have limit x approaches infinity x minus x square ln of 1 plus 1 by x. So let us first do the transformation over here. X is replaced by 1 by t and t goes to 0. Why? Because we are used to of ln of 1 plus t. It would be easier to expand this series rather than this series, right? So that's why I did this transformation. So it would become limit t approaches 0, 1 by t minus 1 by t square ln of 1 plus t, right? Now, if we take the LCM over here, we'll be getting t minus ln of 1 plus t divided by t square. So we can expand ln of 1 plus t now. This is limit t approaches 0. So this would become limit t approaches 0, t minus ln of 1 plus t is t minus t square by 2 plus t cube by 3 and so on, divided by t square, right? Now this becomes limit t approaches 0, this t gets cancelled out and we're left with t square by 2 minus t cube by 3 and so on, divided by t square. If we cancel out t square over here and this one, now we are left with limit t approaches 0, 1 by 2 minus t by 3 and higher order terms, right? Now these higher order terms would be cancelled out, would be negligible, right? Because t is approaching 0, so limit would be 1 by 2, right? Now let us solve one more question. Let fx equals to 4 plus sine 2x plus a sin x plus b cos x divided by x square. If limit x approaches 0, fx exists finite and non-zero. Find a and b and limit. Okay. So these are the three important keywords over here: exists, finite, and non-zero. So let's first write expansion over here. So we have limit x approaches 0. 4 plus sine 2x is 2x minus 2x whole cube divided by 3 factorial plus 2x raised power 5 by 5 factorial and so on, plus a times x minus x cube by 3 factorial plus x5 by 5 factorial and so on, plus b times 1 minus x square by 2 factorial plus x4 by 4 factorial and so on, whole divided by x square. Now, before moving forward with this example, let us try to understand the situation with the help of a smaller example. Let's say we have three cases. Limit x approaches 0, ax square plus bx plus c divided by x square. Limit x approaches 0, ax square plus bx by x square. And third case is limit x approaches 0, ax square by x square. Out of these three cases, in which case limit would exist? Now if we talk about this one, here the numerator value is not 0 because we have a constant term over here. If x is approaching 0, this would go to 0, this would go to 0, this would go to 0, but c would not go to 0 because this is a constant term, right? It may or may not be 0. So in this case, if c is not 0, limit won't exist, right? Because we have something constant number divided by 0. Now same case over here. In this case, we have a 0 by 0 format. So if we cancel out one x, this x and this x. Now again we have 0 term over here, 0 term over here, but we have a constant term over here. Again in this case, the limit would be something constant by 0 and it won't exist. This won't exist. Does not exist. Now in this case, we have x square term and x square term, right? So this would come out to be a. Now let's take one more case. We have limit x approaches 0, ax square plus bx cube divided by x square. Now in this case, x square and this gets cancelled out and we have a constant term over here and we have x approaches 0. In this case as well, we have limit as a. So what do we mean by that? In case limit x approaches 0 and we have a term x square in the denominator, in that case, all the terms of numerator should have a power of at least 2, right? That is x square or higher. It can be x cube, it can be x4, but it should be minimum x cube for limit to exist, right? In case we have a linear term, the limit won't exist. In case we have a constant term, limit won't exist. Here we need exists, finite and non-zero, right? For that case, it should have one term of at least x square. Over here we had ax square, that's why limit was finite. In case we don't have ax square, this would become bx and that would become 0. So if we want non-zero limit, in that case it should have one term of x square and the higher terms can be ignored over here, right? And linear term should not be there, a constant term should not be there. Now that we have understood this, so if we proceed with this one, limit x approaches 0, so the constant term over here is 4 plus b from here, right? And the linear term over here is 2x from here. If you write x over here, 2 from here and a from here, and I don't think we have other linear terms over here. Okay, if we talk about x square, then we don't have x square term over here, we don't have x square term over here, and we have minus b by 2 factorial over here. Okay, and then we have higher degree terms, divide by x square. Now for this limit to exist, this term should be 0, this term should be 0, right? And this should not be 0 definitely. Based on that, we'll be getting b equals to minus 4 and a equals to minus 2. When b equals to minus 4, this coefficient would become 2. This coefficient would become minus b by 2 factorial, that is 2, right? Now this should be the limit because this is not existing, this is not existing, and higher degree terms are 0. So we have limit as minus b by 2 factorial, that is 2. So this is the limit answer. Okay. Now let's talk about sandwich theorem. So it says that if fx is less than equals to gx is less than equals to hx, and limit x approaches c fx equals to L and x approaches c hx equals to L, then limit x approaches c gx equals to L. So let's try to understand this with the help of a graph. So let's say we have this graph, let's say we have this function, and let's say we have this function. Right? We can clearly see that this function is always bigger than this function for all x, and this function is always lesser than this function for all x, right? So according to this condition, this is our fx, this is our gx, and this is our hx, right? Now let's say for a particular point c, we are trying to calculate the limits, and this value over here and this value over here, let's say this value is L plus h, and this value is L minus h. Why? Because limit fx approaching c, limit of fx x approaching c is L. So that's why near the vicinity I have taken L minus h, and over here near the vicinity I have taken L plus h, right? Now gx value is lying between L plus h and L minus h. So gx limit x approaches c is lying between L plus h and L minus h. It's like saying that let's say some fx value, or let's say some kx value is less than equals to 1.0000001 and greater than equals to 0.999999. Ultimately we can see that this is approaching 1, this is approaching 1, so limit is 1 over here, limit is 1 over here, and since this number is between these two very close numbers, the limit would be 1 only, right? So that is the idea behind sandwich theorem. So based on this logic, we can simply say that since h is very small, limit gx x approaching c should be L. Okay, so that is our sandwich theorem. So when do we use sandwich theorem? We use sandwich theorem in case we are not able to apply other types of methods to find out the limits, right? Now let us solve this example, and although we can solve this example with the help of other methods, but let's try to solve this with the help of sandwich theorem. So we have fractional x by x over here, limit x approaching infinity. So for fractional x, we know that this is always less than 1 and greater than equals to 0, right? This inequality holds true for all cases, right? If we try to divide this with x and then take limit x approaches infinity, this inequality would still hold true, right? Because we have just divided by x and x is positive over here, right? Now, if we try to find out this limit, okay, in that case, 0 by x would be 0, limit x approaches infinity, and same with this one, limit 1 by x, x approaches infinity, that would be 0 only. So this limit is 0, this limit is 0 when x is approaching infinity. In that case, this limit should always be 0 when x approaches infinity. Okay, so let's solve one more problem. So we have log of gif function of x divided by x. Now for gif, we know that gif function is always less than equals to x and greater than x minus 1. This is always true, right? Let's take log on both sides. Becomes log of x minus 1 this becomes log of GIF, and this becomes log of x, right? Now if you divide by x, divide by x, and divide by x over here, and take the limit x approaches infinity, right? In that case, this inequality would still hold true because x is positive infinity, right? Now in this case, if we try to find out this limit and this limit, what would be the answer? We can just find out by help of L'Hopital rule, because this is infinity by infinity format. Okay, so if we differentiate numerator and denominator over here, we'll be getting 1 upon x minus 1 divided by 1. So this comes out to be 0 only. And if we differentiate this one and this one, we'll be getting 1 upon x divided by 1. Again, this would be 0. Okay, now this is 0, this is 0, so this comes out to be 0 only, based on sandwich theorem. So let's solve one more question. We have limit x approaches infinity, gif x plus gif 2x plus till gif nx divided by x. Okay, so we'll start with the same method as last question. What we did over there, we know that gif x is less than equals to x and greater than x minus 1, right? Similarly, for 2x, gif of 2x is always less than equals to 2x and greater than 2x minus 1. So similarly for nx, GIF of nx is always less than equals to nx and greater than nx minus 1. Okay, now we'll use this for the entire inequality. So we have x minus 1 plus 2x minus 1 till nx minus 1 is less than GIF x plus GIF 2x till GIF nx is less than equals to x plus 2x plus 3x till nx, right? Now if you divide the entire equation by x, because x is approaching positive infinity, right? Now if we take the limit over here, for this it would become limit x approaches infinity, we have x plus 2x plus till nx, so that would become n plus 1 by 2 x, because that is sigma nx, right? And we have n times 1 minus 1 minus 1 minus 1 minus 1, we have n times minus 1, so minus n whole divided by x. Okay, and for this it would become limit x approaches infinity, so this becomes n plus 1 by 2x whole divided by x. Okay, now we can clearly see that if n is finite, in that case this cancels out, this cancels out, this becomes x, this becomes basically 0 over here, and we have got the limit as n plus 1 by 2. Similarly over here, this x gets cancelled out, we get the limit as n plus 1 by 2. Okay, now we have got the limit as n plus 1 by 2, and both are equal actually. In that case, this limit would eventually come out to be n plus 1 by 2. Okay, so this was more or less the gist of sandwich theorem. What you basically have to do is find out an inequality representing the functions, and then you have to take the limits, see if those limits are equal or not, and if they are equal, in that case the middle function would have the same limit under those conditions, right? So now that we are done with sandwich theorem and examples of expansion series, so let's move forward with the last topic of today's lecture, that is indeterminate forms of 0 raised power 0 and infinity raised power 0, and also 1 raised power infinity. That will study later on. Okay, but as of now, let's focus on these two. Now, as we discussed earlier, these are not exact zeros, these are approximate zeros, same with here. Okay, so the only way to solve this one is take log on both sides, and then you will see that this gets converted into 0 by 0 or infinity by infinity. Then after that, you know, either rationalization, factorization, or L'Hopital. That's a cakewalk, right? So let's try to understand with this example. So we have limit x approaches 0, x raised power tan x. Over here, x is approaching 0, and when x is approaching 0, tan x is also 0. So basically, this is a 0 raised power 0 format. Okay. So what do we do over here? Let's assume that this limit is y. So this becomes limit x approaches 0, x raised power tan x. Okay. Now let's take ln both sides. That would become ln y equals to limit x approaches 0, ln x raised power tan x. Now we know that tan x would go over here. This becomes limit x approaches 0, tan x ln x, right? Now this is approaching 0, this is approaching minus infinity when x is approaching 0, right? So this becomes 0 into infinity format. Now what we can do, we can convert tan x as cot x divided by cot x. Okay, now this becomes infinity by infinity format, and we can use L'Hopital over here. So let's try to find out this limit with the help of L'Hopital. So if we differentiate ln x, we'll be getting 1 by x, and for cot x, we'll be getting minus cosec square x. Okay, now I'll shift this cosec square x in the numerator as sin x. So this becomes sine square x minus n divided by x. Now this limit becomes minus sin x dot sin x by x. This is 1 standard limit, and this is 0. So eventually this limit becomes 0. Okay. So basically this limit is 0 only. So we have got ln y equals to 0. So y equals to e raised power 0, that is 1. Right. Don't leave the question over here only. You have to write y equals to e raised power 0 equals to 1, because we have taken ln on both sides, but eventually we have to find y only. Okay. So this answer would be 1. This method would apply also for infinity raised by 0. You just have to follow the same process. Take ln on both sides, convert that into 0 by 0 or infinity by infinity format, and use L'Hopital or other methods to find out the limit, and then reverse back the process to find out the limit. Okay. Now let's talk about the last indeterminate form, that is 1 raised by infinity, and it is one of the most important indeterminate form. Okay. It looks like limit x approaches 0, 1 plus x raised power 1 by x, and also limit x approaches infinity, 1 plus 1 by x raised power x. They both are same actually, right? Because if you replace x with 1 by t over here, you will get this only. Okay, so they both are interconvertible, and we get the result as e. Now generally, it looks like this one, 1 plus fx raised power 1 by fx. Okay, where fx is also going to 0. Okay, in that case, this result also yields E. Remember, when we talked about the standard limit ln of 1 plus x divided by x, this x meant anything. Anything which goes to 0, as long as it is present over here and here, this result would yield 1 as the answer, right? Similarly over here, as long as we have 1 plus fx raised power 1 by fx, and fx approaches 0 when x is approaching a, in that case, this result would yield E. Now let's see how this comes out to be E. Now, if we talk about the general expansion 1 plus x raised power n, the general expansion, not the binomial one, the general expansion, it would be 1 plus nx plus n minus 1 divided by 2 factorial x square plus n minus 1 n minus 2 divided by 3 factorial x cube and till infinity. Okay, this keeps on going. Now over here we have 1 by x over here, right? What we can do, we can replace n by 1 by x. So this would be 1 plus 1 by x dot x plus this would become 1 by x minus 1 x square by 2 factorial plus 1 by x minus 1 1 by x minus 2 x cube by 3 factorial and so on. Okay, now this gets cancelled out. Now this would become 1 plus 1 plus, now if we take LCM over here, we'll be getting 1 dot 1 minus x, and we have x in the denominator and x in the denominator. Basically we have x square, and this x square gets cancelled out. We'll be getting 2 factorial plus over here similarly we'll be getting 1 dot 1 minus x dot 1 minus 2x divided by 3 factorial and so on, right? Now we know that x is approaching 0, and we have to take the limit, right? Limit x approaches 0 for this one, that would come out to be 1 plus 1 plus. So if I apply 0 over here, it would become 1 by 2 factorial. If I apply 0 over here, it would become 1 by 3 factorial and so on. Okay, now if you remember, e raised power x is nothing but 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Now if I put x equals to 1 over here, we'll be getting e equals to 1 plus 1 plus 1 square by 2 factorial plus 1 cube by 3 factorial, right? And so on. If you see that this is exactly same as this one. So this limit comes out to be e only. Okay. Now let's try to understand a different form of 1 is by infinity, that is this one. Until now what we have seen is 1 plus x is power 1 by x, right? This is what we have seen. But now this is the generic format where fx is approaching 1 and gx is approaching infinity. Okay, so let's see how to solve this one. So if you remember, a raised power x can be written as e raised power x ln a. We'll use the same trick over here. We'll write this as limit x approaches a e raised power gx ln fx. Okay, now one more trick over here. I'll write fx as ln of 1 plus fx minus 1. Okay, it means the same. What we have done is we have added 1 and subtracted 1 over here to make this 1 plus 0 format. As fx is approaching 1, this entire becomes 0, close to 0, right? And this is 1, so this becomes ln 1 plus something 0 kind of format. Okay, and we know that ln 1 plus something divided by something is 1, right? We are trying to use that standard limit over here. Okay, so this becomes limit x approaches a e raised power gx, and what we can do, we can multiply divide by fx minus 1 over here. Fx minus 1 divided by fx minus 1 and multiplied by fx minus 1. Okay, now this limit becomes 1. So what eventually we have got, limit x approaches a e raised power fx minus 1 multiplied by gx, because this limit went to 1. Okay, so this is our final expression. We have to solve all these questions with this formula, and then we have to find out the limit. Once we have got this, now we can find out the limit. Okay, now let's solve this question. We have limit x approaches 0, 1 plus x raised power cosec x. Okay, now we can see that this is not of the standard type. Our standard type was 1 plus x raised power 1 by x. This was the standard type. This is not of that format. This is of the format fx raised power gx. And for that, our formula is e raised power limit x approaches 0 fx minus 1 multiplied by gx, right? This is the formula. So over here fx is 1 plus x. So let's write that 1 plus x minus 1, and gx is cosec x. We have cosec x limit x approaches 0 e raised power. Okay, now this 1 gets cancelled out, and what we're left with, e raised power limit x approaches 0. Now this is x and we have cosec x. We can write this as sin x, 1 by sin x, right? This becomes x by sin x. This is the standard limit, right? This is 1. So the answer is e raised power 1. Very simple. Now let's solve this question. We have limit x approaches 0, a raised power x plus b raised power x plus c raised power x divided by 3 raised power 2 by x. Now as x is approaching 0, a raised power x goes to 1, b raised power x goes to 1, c raised power x goes to 1, and this entire becomes 1 raised power infinity format, right? Now for that we'll be using that same format, e raised power limit x approaches 0 fx minus 1 multiplied by gx, this format, right? Let's use that. Let's try to find out this expression first. We have fx minus 1 as a raised power x plus b raised power x plus c raised power x divided by 3 minus 1 multiplied by 2 by x. Okay, now if we take the LCM over here, it would become minus 3. Now we'll distribute this 3, 1 over here, 1 over here, and 1 over here. So it would become a raised power x minus 1 plus b raised power x minus 1 plus c raised power x minus 1. Why we did that? To form this kind of setup, this kind of a standard setup, right? Multiplied by 2 by x. Now what we can do, we can take this x over here, okay, and take this 3 out. This would become a raised power x minus 1 divided by x plus b raised power x minus 1 divided by x plus c raised power x minus 1 divided by x whole multiplied by 2 by 3. Okay, and now we know that this limit is, if we take the limit now, this limit would be standard limit, that is ln a, this is ln b, and this is ln c multiplied by 2 by 3. Now if we use the log properties over here, we'll be getting 2 by 3 ln a b c. Okay, now 2 by 3 can be raised to over here because of log property. Once again, we're getting ln a b c raised power 2 by 3. Now the original limit was e raised power limit x approaches 0 ln a b c raised power 2 by 3. Now if you again use the log property with this one, the answer would be a b c raised power 2 by 3. Okay. Now this particular question involved multiple concepts. 1 raised by infinity, standard limits, log properties, basically 3 concepts in one single question. And you can expect these kind of questions in actual examination because increasing difficulty. Okay. And now for this question, I'll leave this for homework because this is much simpler as compared to previous one. And you just have to apply the direct formula over here. That is e raised power fx minus 1 gx. Okay, just apply the formula over here and you'll get the answer. So with this, the end of lecture is here. And also we have wrapped up the entire syllabus of limits for PGDBA 2024. You will not get any question beyond these kind of concepts if you are concerned with PGDBA, right? You just need to practice more and more questions for these concepts. Okay. So let's meet in the next lecture and we'll continue with continuity. Okay. Thanks for watching.